Okay, here's a traffic light problem that we started in class today, and we finished, but we didn't actually finish all the math. So I'm putting this up here just in case you need it to go over. So you have this traffic light. It's got a weight of 122 newtons. So we know weight is your force of gravity. So we're going to analyze this. We're going to draw two free body diagrams. The first one is going to be for the stoplight itself. And we know that the force is going to be the Fg. And up here is your tension, your third tension, T3. Then we're going to use the knot where the three join together. And we're going to draw, this is T2. And that's at 53 degrees. This one is T1. That's at 37 degrees. And then we have that tension, and the rope is actually pulling down, and that's T3. Okay, so this is your actual free body diagram. For example, if you had something on the AP test, you would draw this. Now what you actually have to do though, let's just pop that back up. I wrote those backwards. So we get T3 and Fg, and (53), that's T2. We have T3 out this way at 37 degrees, and that's T1. And your T3 is down here. So what you have to do is you have to break those into components. So you're going to have T2 cosine of 53 degrees. And that's because this angle here is also 53. And that's your T2 sine 53. All right, and if you want to be specific, you could say T2y, and that's T2x. Then you come over here, you do the same thing. And it'll be T1 cosine 37, and that's your T1x, and your T1y is T1 sine of 37. Okay, so at this point we're going to use our second law. We're going to sum up all the forces in the y direction. Let's do it for the traffic light. And we know that it's in equilibrium, so we know that it's going to be 0 because our acceleration is 0. Then we just read right off of our free body diagram, so we'll have T3 minus Fg equals 0, and we find out that the tension right there is going to be equal to the weight of the traffic light itself. Now we're going to come over here, we're going to sum all of our forces in the x direction, and we're going to sum all of our forces in the y direction. We know that it's in equilibrium, so we know there's no acceleration, and therefore it equals 0. So let's write all this stuff out. In the x direction, we have this guy and this guy. You just have to be careful of your signs. So it'll be T2 cosine 53 degrees minus T1 cosine 37 degrees equals 0. In other words, T2 cosine 53 is equal to T1 cosine 37. They have to be, because they're the only two forces in the x direction, and it's in equilibrium. So this tension and this tension have to balance each other out. So what do we have in the y direction? Well, we have T2 sine 53, T1 sine 37, and don't forget about T3. So we're going to put that in there. We've got T2 sine 53 plus T1 sine 37 minus T3 equals 0. Okay, so what we have to do is let's solve T2 in terms of T1. And then we're going to use this and put it in here. I'm going to do that math on the next slide. Okay, so we had T2 sine 53 plus T1 sine 37 minus FG, which we know is coming from the fact that T3 equals FG. All of that is equal to 0. Let's plug in. We're going to get T1 cosine 37 cosine 53 that's your T1. That's being multiplied by sine of 53, and then you're adding T1 sine 37, and then I'll just bring FG over here. That's actually a number, so we can put a number into that. That's not a big deal. What we're going to do a little bit of simplifying. If you look here, we have a sine over cosine. So you can do that. We also have a T1 in this term and a T1 in that term, so I can pull them out. So I could end up with T1 is what's left, cosine 37 times the tangent of 53 plus, now remember he's out here, I only have sine of 37 is equal to FG. So at this point you can just solve for T1 and you get FG all over this giant expression. Cosine 37 tan 53 plus sine 37. Now you might have added numbers earlier on, that's fine. You'll see that the longer you hang on to your variables, the easier it will get. So if I just plug in the numbers that we have there, these are all just numbers. This was 122 newtons. We get T1 equal to 73.4 newtons. And then on the next page, we're going to use that to find T1. No, to find T2. All right, so T1 equals 73.4 newtons. And we have this expression, T2 is 73.4 cosine 37 all over cosine 53. And T2 is equal to 97.4 newtons. So here's my T1, here's my T2. The original question was posed that if the tension is higher than 100, those cables will break. So this one comes really close. This one, totally fine. This one comes close, but the tension in the cables will not cause them to break. So that's that example. Lots of fun.